Welcome to Rotgans Research. We read brains to boost performance. For too long, cutting-edge neuroimaging has stayed inside the lab. We take it to the flight deck, the operating theater, the command center, any environment where split-second decisions matter. In the next few minutes, you'll discover how our 5 functional pillars, ROI Library, Spearfish Real-Time Analytics, Performance Benchmark Method, NeuroTargeted Training, and crew-level Hyperscanning, push applied neuroscience far beyond conventional wearable brain tech. Whether you lead special operations units, critical care teams, or advanced pilot training schools, this is applied neuroscience built for your world. Let's begin. Let's begin with the tool we use to measure brain activity in authentic operational settings. fNIRS stands for Functional Near-Infrared Spectroscopy, a non-invasive neuroimaging technology that measures brain activity by detecting changes in blood oxygenation. Unlike traditional EEG, fNIRS offers deeper and more localized insights, especially in the prefrontal cortex, where critical thinking and decision-making take place. At Rotgans Research, we use NeuroSit by Obalab, an advanced medical-grade wearable fNIRS headset that delivers real-time, high-resolution brain data, even in complex operational environments. It's non-invasive, wireless, easy to set up and calibrate in just a couple of minutes, comfortable to wear for prolonged periods, and supports advanced data analytics and real-time visualization. Let's start with the first pillar. In our analysis, we don't just track general prefrontal activation, we focus on 5 validated regions of interest, each tied to key mental functions: uncertainty, executive control, strategic planning, adaptability, and visual attention. Unlike EEG, which struggles to localize cognitive processes in real-world environments, our fNIRS-based ROI mapping delivers precise, region-specific insights, even under operational conditions. This means we can detect a surge in uncertainty during a critical phase of performance, or identify when someone engages in strategic planning to anticipate and adapt under pressure. We're not just measuring brain activity, we're decoding how people think in real time. At Rotgans Research, we developed a bespoke algorithm called Spearfish, a proprietary spike detection engine built specifically for fNIRS data. Spearfish achieves over 90% accuracy by filtering out noise and motion artifacts, isolating true cognitive activation with high precision. It detects exactly when significant brain activation occurs, both at the level of total prefrontal activity and within each of our 5 targeted ROIs. These results are visualized in an activation matrix, giving a rapid overview of when and where meaningful cognitive events took place. To deepen the insight, we link these moments directly to video recordings, automatically cutting and exporting segments tied to each spike. This lets us examine not just brain activity, but what was actually happening at that moment. Monitoring brain activity during task execution isn't new. Tracking intra-individual changes, such as pre-post comparisons, is standard practice in neuroscience. But to truly evaluate performance, an external reference is essential. That's where our performance benchmark method comes in. We record the brain activity of an expert, someone who performs the task fluently and under pressure. This neural signature becomes the gold standard. Each trainee's brain activity is then compared directly to this benchmark, not just to assess engagement, but to evaluate how closely they match expert-level cognitive patterns. We quantify this using the Euclidean distance between the novice and expert activation profiles across specific regions of interest. This provides an objective, interpretable measure of cognitive performance gaps. Once we've identified the cognitive gap between expert and novice, we move to the next step: neuro-targeted training. By statistically comparing the activation matrices of experts and individuals, we pinpoint exactly where someone's brain activation diverges, whether it's a missing engagement in strategic planning or excess strain in executive control. This method allows us to design targeted interventions, not general drills, but focused training aimed precisely at the individual's weak points. It also enables highly specific, evidence-based feedback, crucial for learning in high-stakes environments. With this approach, we've observed 30 to 40% reductions in training time and up to 74% increases in training efficiency, simply by identifying and addressing individual cognitive gaps rather than applying one-size-fits-all solutions. Measuring individual brain activity is valuable, but in many high-stakes professions, performance depends on the team. In fields like defense, aviation, or medicine, evaluating a single person in isolation is not enough. That's why we developed our crew-level hyperscanning algorithm. CLH tracks not just individual mental workload, but the collective cognitive load of the entire crew in real time. It enables us to see when the crew as a whole is nearing cognitive overload, and more importantly, which team member is under strain and who has capacity to step in. We're currently developing orchestration software that leverages this data to recommend dynamic task reassignment, supporting better decisions, safer outcomes, and more resilient teams. One of the most impactful outcomes of crew-level hyperscanning is its ability to inform evidence-based automation. By measuring real-time brain activity across individuals and teams, we can objectively identify where cognitive overload occurs, whether it's an expert pushed to their limits or a crew experiencing collective strain. These insights help determine which tasks should be automated and when, not based on assumptions, but grounded in neurophysiological data from real-world operations. Traditionally, automation decisions have relied on guesswork or subjective judgment. Our method introduces objectivity, granularity, and operational relevance across the entire automation lifecycle. With this approach, we can identify automation needs, inform system design, guide lab testing, and critically, evaluate whether the solution actually reduces mental workload in practice. For an example of this application, see our publication on how fNIRS was used to assess the effectiveness of automation in lowering cognitive load. In a world increasingly shaped by automation, neuroscience can lead the way, ensuring these systems are not just efficient, but truly aligned with human cognitive capacity. At Rotgans Research, we believe that cutting-edge neuroscience belongs outside the lab, where performance matters most. From real-time spike detection and expert benchmarking to precision training and crew-level hyperscanning, our 5 functional pillars bring clarity to complex operations. We provide leaders, trainers, and system designers with the tools to understand how people think, not just what they do. Whether you're building elite teams, optimizing high-stakes training, or designing automation that truly supports humans, we're here to help you get it right. Thank you for your kind attention.